Hello students, and welcome to Mr. Graves' algebra class. Today we're going to be talking about factoring trinomials, and want to explain how to do that. I've got some problems on the board, but before we do it, in my math class we've already talked about the multiplication of binomials, and I want to go over that first because I think in doing one problem it'll help you understand why we're doing what we're doing. And so right here we have a problem that's x minus 2 times x minus 3. My students know there's two ways we go about it. You might have a personal preference. It does not matter to this teacher as long as you're neat and you do the problems right, the math correctly, and you bring it down to get the right answer. First of all would be stacking it. We could take x minus 2 times x minus 3, and we can stack it like we normally would with a regular math problem, much like you would multiply 14 times 16. And you would do that. Negative 2 times a negative 3 is a positive 6. Negative 3 times x is a negative 3x. And then a negative 2 times x is a negative 2x. And then x times x is x squared. And what we do here is we'll put a line underneath, and then we'll go ahead and combine like terms, or basically add our columns. So we have 6, and then a negative 3x and a negative 2x combined, same sign, we add, we keep the sign, would be a negative 5x. Remember, we don't do anything at all to the letter, we're just combining like terms. And then we have x squared, and we'll bring that down. That's the first step, the first way or method that we can do that in multiplying two polynomials. The other specifically would be FOIL. And if you've been in algebra or you know algebra, you've probably heard the word or the acronym FOIL. The F, letter F, stands for first. So we take the multiplication of the first two in each binomial, and we get x squared, x times x. All right? And then we do the last. L stands for last. So negative 2 times a negative 3 is a positive 6. We'll put that on the end. And then what we do for the O and the I is the outer and the inner. So what I like to do is take or connect, using a little bit of a rainbow, the outer terms with a spot here, or space in the middle, and the same for the middle, the inside actually. So I have an x times a negative 3, which is a negative 3x, and then I have negative 2 times x, which is a negative 2x. And then once we've done our multiplication and we've put them there, kind of in our rainbow, then we add those two and we get a negative 5x. Both methods work, you do them right. Again, it's personal preference to you, but we have our problem. Now, what we're going to do today is we're going to learn how to actually factor trinomials. And the way we go about doing that is this. And this kind of sets the base or the tone for what it is we're doing. These are problems that you probably have already learned, or at least you have in my math class, and you've taken these binomials and you've turned them into what we call a trinomial. Most all of them come in 3 terms. But now what we're going to do in this particular lesson is this. We're going to take away those binomials that you were multiplying and using your methodology, and we're just going to only give you the answer. That's all we're going to do. The trinomial itself is in your lesson, in your book. There's several of them, obviously you do for homework. And your goal is to master what we call factoring, or factoring a trinomial back into two binomials. And there's a way to do that. Some people get it, some people don't, maybe right away. And if you don't get it right away, you can always just replay the video, and we can try to go through it again. But what we do here is we've got several trinomials on the board. I've written here at the very top, and this will mean more to you as we continue to go through the lesson, find two numbers that when multiplied together equal the last, but when they are added, they equal the middle. And here's what we mean by that. The first thing we'll do is we're going to factor this. Obviously we remember what the answer was, but we're going to come up with the answer in the right method. So we put 2 sets of parentheses, and in doing so, we're going to go ahead and put down, we know that x squared is our first term. That was derived from having x times x. That was the F part of FOIL, using our first term in each one. So we know that that is true. But here's what we're going to do. In our terminology here, as far as finding two numbers when multiplied together, one of the big essential parts of trying to find the two binomials is taking the last number and factoring it. This here's a positive 6. In this particular problem, we have a negative 6. Here's a negative 72. positive 15, negative 32, negative 28, examples that we're going to do here quite quickly, but we're going to try to go through them. And what we need to do is we need to actually find the factors of positive 6. So in doing so, 6 is pretty easy. In another video, I might show you how to break down the product of prime. We've taught this to our students. We start with the lowest prime number we can, and that's a 2 because it's an even number. So we have 2 times 3. So our factors of 6 are 2 times 3. We also know, and we can never forget and always have to remember, that we have 6 times 1 as well. Okay? One thing that we might want to realize, and you're going to have to just learn, numbers like negative 72, negative 32, even negative 28, those are numbers that have many factors to them. Several more sets than just a 6. 6 is just 1 and 6, 2 and 3. That's pretty easy. And some of these will come to you over time, but some of them will take some time. And you're going to need to factor so that you can kind of see and make a list of the factors that you're going to need to solve this problem. Over time, you'll get better at it. You may not even have to list all the factors. They might be there for you. You can kind of see it and understand what's going on, especially in the second term, that when you add them together, they become the middle number. So watch what we do here, all right? Not only are 2 and 3 factors of 6, not only is 6 and 1 a factor of 6, but we actually have to remember that a negative 2 times a negative 3 multiplied together is also a factor of 6. And that negative 6 and a negative 1 multiplied together is also 6. So we actually have 4 sets here. So let's do this, all right? Here's what we've done. We're going to do this and engage this rule in every trinomial that we factor. The first thing we do is we list our factors. Go ahead and put our set of parentheses, our letters. We'll list our factors out. We know that every one of these factors find 2 numbers when multiplied together equal the last number. So here's the list. They all multiplied in sets equal the last number. We've compiled the entire list. There are no more factors of 6 that we can do, but we also need to make sure that we have the negatives involved in that. Okay? Now, in the second part of our rule, when they are added, they equal the middle. So all we have to do is simply take each individual set and add them together, and which set of the 4 gives me the middle number, negative 5. So 2 plus 3 is 5. But 5 is not negative 5. 6 plus 1 is 7. That's not negative 5. Negative 2 and a negative 3 added together. Negative 5. So negative 2 and negative 3 are the factors that complete our 2 binomials as we factor this trinomial. So we put x minus 2, x minus 3. Obviously, a negative 6 and a negative 1 added, or negative 7, that would not be the case. So these 3 will not work. The process of elimination and the first problem here that we do, I generally explain a little bit more into detail. Be patient with me. The others will go a little quicker. And again, you can always rewind and check them out. So x minus 2 and x minus 3 are actually what we had originally on the board. And we did both our stacking as well as our FOIL to get x minus 2 and x minus 3. But if you follow this rule each time, you'll come up with the answer. And of course, you can always check yourself using both methods or one of the ones that you would like to use. So I'll tell you what, let's move on to y squared plus 5y minus 6. So what are we going to do? We're going to go ahead and put 2 sets of parentheses here. We know that y times y is going to be y squared for the first part. And now we need to list our factors of a negative 6. Now here, we had a positive 6. But in this particular trinomial, we have a negative 6. So in doing that, we have a negative 6. All right. We know that 3 and a negative 2. All right. We've got our list right here. 3 and a negative 2 equal a negative 6. How about a negative 3 and 2 equal a negative 6? Remember, to be negative, one of the 2 terms has to be negative when we multiply in order for the answer to be negative. And then our 6 times 1, we can't forget that. So we've got a negative 6 and 1, and a 6 and a negative 1, okay? Now again, 6 is easy because there's really only 2 types of factors there, and then when we do the negative, it becomes 4. And running 4 is pretty easy. We've got a lot of other bigger numbers coming up, okay? So now, we found the numbers when multiplied together is our last. All of these multiplied together comes to a negative 6, but all we got to do is look at each set of numbers, add them in our mind, and then find out which one gives us a positive 5. So 3 plus a negative 2 is 1, and for my students, different sign, we subtract, keep the sign of the larger, remember that? Negative 3 and a positive 2 would be a negative 1, all right? Negative 6 and a positive 1 would be a negative 5. We're not there yet, but we certainly have eliminated the 3 that we know do not work. So it must be the last one. 6 and a negative 1 added together equal exactly what we want, a positive 5. So positive 6 for one binomial and a negative 1 for the other binomial. And there's our answer. All right? Let's go to x² plus x minus 72. All right? And we're going to move along here. X and x. All of the factors of a negative 72. I'm going to go ahead and erase this just for a little bit of room. All right, so let's do it. All right, negative 72 and the factors. Now, in order to list that, my students know that we break everything down in the product of primes. Some of you may use the tree method. I like to just use the upside down division bar. So I take a 72, I divide that. I'll maybe do another video on doing this so that I don't make this one longer and you understand it's an even number. We're going to use 2, all right? And then 36, and then we'll go 2, 18, 2, 9, 3, and 3, okay? So 2, 2, 2, 3, and 2, or 3, sorry, all right? And that's what we've got. So negative 72, so we've got, if we just take this 2, we've got 9, 18, so we got 2 and a negative 36 and a negative 2 and 36. So what I'm going to do is just do the negative of one and then the negative of the other, all right? And you've got it. So now I'm going to do 4. So 4 times 18. So 4 and negative 18 and negative 4 and 18, all right? So I did the first number and then the rest. I did the second number and then the rest. I'm going to do the third number. So I've got 8 times 9. All right? And you can see that. And then the fourth number, I'm going to use all 4. And I've got 3 times 24. So 3 and a negative 24 and negative 3 and 24. Okay? 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 actual sets, all right? Even though there's really only 4, but we had to kind of do the negative and positive. And we had to do that because this is a negative 72, all right? Now, if we did a positive 72, remember, we would actually have to do a negative 2, negative 36, and 2 and 36. We'd have to do a 4 and an 18. We'd have to do a negative 4 and a negative 18. We'd have to do 8 and 9 and a negative 8 and a negative 9. So we'd have to do those factors if this was a positive 72. But if it's negative, we have to make sure that 1 is always negative, and we put one number as the negative, and then in the other set of numbers or factors, we put the other as negative, okay? So make sure we do that. Now, it's a long list. It might be a little laborious at first. 72 is a bigger number. There's some trinomials that are in the book, and there's some bigger numbers. I call it fun. I'm not sure what you call it, but I love it, all right? And it's just good. So here's what we'll do. We'll go through, and we did the first part. Now we're going to do the second. Which one of these numbers, when you add them, equal the middle number of 1? It's not listed there, but we understand it in algebra as 1. All right? No, 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 no. Look at the beautiful set of factors right here. Perfect. Negative 8, positive 9. This is my ticket to a right answer. because both when added equal the middle. So negative 8, x minus 8, x plus 9. So find two numbers that when multiplied together, negative 8 times a positive 9 is a negative 72, the last. But when added together, negative 8 plus 9 equals a positive 1, x in the middle, all right? My students, we're always talking about getting the sign numbers right. Negative 9 isn't what you want to write, because the larger number is negative on the 9 and then being negative x, this is a positive x. Don't do that, all right? Let's go to a squared plus 8a plus 15. 15 is a little bit simpler. I think we can handle that. So let's go ahead and put two sets of parentheses here. Then we got our a's. Let's take 15 for a factor. We'll go 3 and 5. Easy enough, I like that, two factors of 15. And but we do need to write it out. So 15 and 1, all right? And then we've got negative 15, negative 1, all right? Because both multiplied together are still positive. And then we've got 3 and 5 and negative 3 and 5. Whoops, 3, negative 5, negative 3, 5, all right? That's what we've got. Now, all we do is pick from one of the four. We've already basically established our factors. All right, when multiplied together equal to last at a positive 15. All right. Oops, sorry about that. I messed up. There we go. Got it. 3 and 5, negative 3, negative 5. Sorry about that. All right. So in doing so, which numbers added equal the middle of positive 8? All right. Looks like 3 and 5. Positive 8. So plus 3, plus 5. You can put those in each answer in any order you want. You can put x plus 9 if you'd like, and x minus 8. You can make this a plus 5 and a plus 3. Totally up to you. All right? Let's do this one here. X squared plus 4x minus 32. We'll put our set of parentheses. We'll put the x. Negative 32. We're going to break that down. We'll start with a 2 because it is an even number. So we get 16 cut in half. We get it cut in half again, cut in half again. And we all know that 32 is 5 2's. All right? So let's get all the factors. Let's extract all the factors we can. What I like to do, take the first 2 and make that part of the factor. So 32 is going to be, here we go, all right? 2 times, all right, negative 32, 4 2's is 16, right? So negative 2 times 16 and 2 times the negative 16, all right? And then the next 2, we'll do 2 now. 4 times 8. So negative 4 times 8 and 4 times a negative 8, okay? And then we'll take the 3, which is 8 times 4. So negative 8 times 4, just take these out of here, that way you don't look confused, all right? And then 8 times a negative 4, okay? And looks like we've got them all down. So those are all our factors, all right? 2, so we've got them all, 4 times 8, let's see, 8 times 4, so we got them all down, all right? And the other one would actually be 32 and 1, okay? Not likely, but you got to put it all down, so we'll never know. All right, positive 4 is our middle number. So the second part of our phrase, find the one when added together. So I'm looking at all these, want to add them all up, and what am I looking for? I'm looking for positive 4. Not going to work, not going to work. Ding, 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 right there. Negative 4, positive 8, all right? So minus 4 plus 8. Two numbers when multiplied together equal this, but when added together equal that. There's our answer. One last one, a squared plus 3a minus 28. Let's take the factors of 28. We'll break that down into the prime primes. We'll divide it as 14, then 2, then 7. All right? So a negative 28 broken down. Let's try to do that and see what we come up with. A and A. All right? That's a bad looking 7. Sorry, my students wouldn't like that. Okay? Negative 28. So 2, 2, and 7. So let's take what? 2 times 14. So negative 2 and 14, and 2 and negative 14. All right? And then we got 2 and 2, which is 4. 4 times 7. So 4, negative 4 and 7. 4, negative 7. All right? And then we've got 28 and 1. Negative 28 and 1, 28, negative 1. All right? So the middle number is a positive 3. We look at our 6 sets. Which one added gives us that positive 3? Our ticket to the right answer, negative 4 and a positive 7. There's the answer. All right? Is that easy for you? Do you get it? I hope that helps. This is the reverse of those binomials that we've been multiplying. So you get that trinomial all by itself, and what we do is we factor, we put it back into the binomials. There's some other lessons that will come up there's some two-step factoring as well coming up. It's all good stuff, I'm just telling you that. But hopefully that'll help you. Don't forget, you're looking to put 2 sets of parentheses. You're looking to go ahead and list all of your factors of that number, all right? And then make your nice list. And again, if it's positive, always if it's positive, you're always going to have the positive and then the 2 negatives. So not just the 15 and 1, but the negative 15 and 1. Not just the 3 and the 5, but the negative 3 and 5, all right? And don't forget that you always have that number at 1 as a factor set. You got to remember that. So factor each number that's at the last. Get your list of factors, write them down, and then how are you going to choose? You're going to choose by the second rule. Which set, when you add them, give you that middle number? And that's the beauty of completing your factoring as we factor these trinomials. All right? Thank you, and have a good day.